Math used in flute. The flute, a simple yet elegant wind instrument, relies on mathematical principles of acoustics, frequency, and air pressure to produce clear and melodic tones. Let's explore the role of math in the flute. Flute uses math in sound, frequency, and air column length. The frequency of sound waves in the flute is determined by the length of the air column, calculated using the equation equals V2LF equals frac V, 2LF equals 2V, where VVV is the speed of sound and LLL is the length of the tube. Hole placement and pitch control. The placement of tone holes follows precise mathematical ratios, ensuring correct pitch transitions between notes. Resonance and standing waves. Mathematical principles of standing waves dictate how air vibrations produce different harmonics and octaves in the flute. Tuning and equal temperament. The flute's tuning system follows a logarithmic frequency scale, where each semitone is separated by the 12th root of 2/1.059 to maintain harmony. Airflow and pressure dynamics. The speed and pressure of air blown into the flute influence pitch and volume, governed by Bernoulli's principle and fluid dynamics. Mathematical principles applied, wave equations and frequency formulas determine the pitch and resonance of notes. Logarithmic progression governs the spacing of tone holes. Fluid dynamics and Bernoulli's principle control airflow and sound production. Mathematics in the flute shapes its melodious tones, ensuring precision in sound, pitch, and resonance for flawless musical expression.